All right, last but longest, we have yet another very peculiar, ugly-looking function. Now this one, we're going to see later on, there is another way to do it. And there's a couple of ways we could do it actually. But it is overall a quotient. And then in the bottom of the quotient is a product. So we're going to do it treating that bottom as a product, but we could also distribute the square root of x through to each term, and then it would just be kind of ugly polynomial, but the derivative part would still work. So I'm going to do this just to show you that you can do a product rule inside a quotient rule. It's ugly, but it can be done. All right, so f prime of x, low d high. So our high is the number -9. What's the derivative of -9? 0. So that whole part gone. Yes. Minus low d high minus high. So minus from the formula. And then high is negative. So that will eventually become a +9. But there's like our formula versus what's going in there. And then over here, I'm going to write d dx of the square root of x times x squared plus 2. Of the square the denominator, and away we go. All right, so we'll come back and clean up that denominator. But what I want to do right now is make a sidebar where we actually work out the derivative of that product rule. Which I'm going to go ahead and write this as yes, the battery is dying. X to the 1/2 times x squared plus 2. All right, so our first guy, x to the 1/2 times the derivative of the second guy, x squared, the 2 comes down, so it's 2 times x to the 2 minus 1, which is 1. So I'll sketch it in there, but eventually, like, I'll stop writing it when the power is going to end up being 1. Plus the derivative of 2 is 0. And then product rule is plus. Now we'll keep x squared plus 2. And we do the derivative of ugly over there, which becomes 1/2 x to the -1/2. All right, we can clean this up a little. Remember that one there? It's just x. And then the plus zeros, nothing gonna go away. So I have x to the 1/2 times 2x to the first. So this is gonna become 2x to the 1 plus 1/2 is 3/2. Plus x squared times 1/2 x to the -1/2. So we'll have the half. X to the 2 times x to the -1/2. We do 2 minus 1/2, which becomes 3/2. plus 2 times a half is just 1. So then it'll be plus x to the negative 1/2. All right, we can combine the front two. They're both x to the 3/2. So I have 2 of them plus another half. 4/2 plus 1/2 is 5/2. So our like most simplified would be 5/2 x to the 3/2 plus x to the negative 1/2. Now remember that front thing is 0. So I just have 9 times that crazy thing over. Now the denominator squared, normally I would leave it alone, but this denominator is a product. So I like to usually like apply the squared to both things in the product. So square root of x squared is just an x, and then x squared plus 2 whole thing squared is x squared plus 2 whole thing squared. If we were going to multiply that out further, we'd have to FOIL it. Don't need to. I was only doing this step because the square root and the squared behaved nicely. But there is our very crazy nested product quotient. Now, for comparison's sake, way over here, that top thing, remember I said we could also multiply through? So x to the 1/2 times x squared becomes x to the 5/2 plus 2 times x to the 1/2. So that is still just what the denominator equals. But now when we do the derivative, we don't have to do the whole product rule. We're just doing the power rule twice. So x to the 5/2, bring the power down. 5/2 x to the 5/2 minus 1, which will be 3/2, plus 2 times the 1/2 comes down, and then x to the 1/2 minus 1 is negative 1/2. And now take a look at what we had. A little simplification, and it is the same thing. All right, so on a lot of these problems, there's more than one way to think about it. And once we learn the chain rule, you'll see we can even do the chain rule instead of, like it's a product chain rule instead of the quotient rule. All right, now this one here is defining h in 2 different ways. So our first h is x times f of x plus 4 times g of x. And they're asking for h prime of 1. And then over here, we've got a little table that tells us the function values at 1 and the derivative values at 1. Okay. So before we can do h prime of 1, we should do h prime of x. Now our x times f of x, that is a product rule. So it'd be x times f prime of x plus f of x times the derivative of x is 1. Boy. No. plus 4 times g of x. When we do the derivative, the 4 is a constant multiple, so we just keep the 4, and now it'll be times g prime of x. Now they wanted h prime of 1, so now everywhere there's an x, I'm going to fill in a 1. So this is a 1 times f prime of 1 plus f prime of 1 plus 4 times g prime of 1. I put an extra prime there when I shouldn't have. So 1 times f prime of 1 plus just f of 1 plus 4 times g prime of 1. So f prime df dx of 1 is -4. So 1 times -4 plus f of 1 is +4 plus 4 times g prime at x equals 1 is -3. And then we just got to crunch the numbers. So -4 plus +4 is 0, plus 4 times -3 is -12. So using our rules, we make it happen. Now we have one more, 1 over x, and a quotient. Now notice here the g over f. Our original quotient rule was f over g. So you have to be very careful about paying attention to where your letters are going if you're using the straight formula. That's why I like low d high over high d low. You're not going to see low or high as function names. And then our 1 over x guy here, I don't want to do a quotient rule with that. I'm going to rewrite it as x to the -1. All right, so when I start doing my h prime of x down here, that first part, we bring the power down, -1 times x to the -1 minus 1. So that'll be to the -x squared. Yeah, to the -2 power. Plus the mess. All right, so low, which is f of x, d high, which is g prime of x, minus high, which is g of x here, d low, which is f prime of x, over square the denominator, which is f of x, and away we go. So low d high minus high d low, squared the denominator, away we go. Yes. All right, and now the number they want us to put everywhere is a 4. So h prime of 4. We have -1 times 4 to the -2. So that'll end up going in the denominator, 1 over 4 squared, which is 1/16, times the -1 will be -1/16. So I'll just go ahead and write that result here. Plus. So now we have f of 4. F of 4 is 10. G prime of 4, G prime, when x is 4, is this -12. Minus G at 4. G at 4 is -8 times f prime, df dx at 4, which is positive 8, over our denominator squared. So f of 4 was 10. So it will be over 10 squared. Now this is technically right here, all numbers. You could type this on the calculator, enter your SD or FD button to tell it, give me the fraction, and you're done. I don't have the fancy calculator, so I will crunch the numbers by hand. So 1/16 plus negative 120, and then this would be plus 64 over 100. Oh, so what do we get? Negative 56? All right, so 56 is divisible by 4. And 100 is divisible by 4. 56 is actually divisible by 8. It's 7 times 8. But 1/16 minus 4 goes into 50. 4 goes into the 5 once. Minus 4 leaves 16. So that's 14 over 100 divided by 4 is 25. Common denominator between 1/16 and 14/25 is whatever 16 times 25 is. So that is 4 times 25 times 4. So 100 times 4, 400. So this one will be times 25 over 25. This one will be times 16 over 16. So 25 minus 4, carry 2, 6, 1, 6, 224. All right. So we're going to get negative 199 over 400. And this should be the moment where you say, I am so grateful for my calculator and not having to do this stupid thing by hand. As long as you're comfortable getting your calculator to spit out the fraction, it's worth it. And then at the end, we have our lovely summary. So we will look at derivative as a rate of change. So we're actually going to look at some applications with position, velocity, and acceleration. See you on Friday.